Hey everybody, this is Mr. Munson. We are continuing Unit 8 Quadrilaterals. This section is quadrilaterals and coordinate plane X and Y axis stuff. This video is dedicated to Eric in my 4th period class who loves Philly cheesesteaks, and I know you do too. So put the video on pause, stare at that incredible luscious sandwich until you are ready to go on. When you are ready, press play and let's get started.
All right, some of the tools that we'll need in this section as we're working in the coordinate plane are the distance formula, slope formula, and midpoint formula. So the distance formula, if you remember, is just basically you take the x's and the y's, you subtract them. Don't forget to square them. And then you take those two new numbers and add them together. What I would like you to remember is that the distance formula is really based on the Pythagorean theorem, right? And so if you can remember the Pythagorean theorem, you square everything. So what ends up happening is you get d by itself by taking the square root of d, and you end up with all this stuff over on this side. Okay? So it's really based on the Pythagorean theorem. All right, so one of the other things that we'll need is the slope. Now, with the slope, we remember that in this case, the y's are on top and the x's are on the bottom, and we're again going to subtract them. And so, quite often we'll talk about, rise over run. The rise is up and down, and the run is left and right. Okay, so rise being the up and down being y's, and the run being the x's. Some of the applications, some of the things that we want to remember about the slope is that parallel lines have equal or same slope. So if I'm looking at two lines and I find their slope using the slope formula, and I find they're exactly the same number, then I find that they're parallel. If they end up being opposite reciprocals, then they're perpendicular, meaning they form right angles. And you can imagine we would want to use that idea in the coordinate plane to show something's a rectangle because that has right angles. Or maybe show diagonals or perpendicular to show something's a rhombus. Okay? And then lastly, one of the things that we'll want to remember is the midpoint formula. So the midpoint formula helps you calculate an x value of a midpoint. And remember, a point is an x and a y. So there's how you'd calculate the y value. Okay? Make sure you know how to use those as we move forward. So one of the I can statements that you need to be able to do in this section is to be able to determine, what kind of shape is this. And so, starting off, it kind of looks like a parallelogram, but I would want to start checking attributes of this thing with the distance formula, the slope formula, and possibly midpoint formula to figure some things out. Okay, so I'm going to start with just check and see if it's a parallelogram. Can I prove that the opposite sides are parallel? Now, one of the things I want you to remember is that anytime lines go straight across the grid, that was a horrible one, two lines that go across the grid perfectly like that are always parallel, right? And the same thing is true for up and down lines. If they're going straight up and down the grid there, then they are parallel. Okay, so what we can do is we can quickly determine that these are parallel because it's exactly what's going on. But DC and BA, I'm not so sure, are parallel. So let's use our slope formula to calculate what that is. So one of the first things I would want to do is find out what those points are, A, B, C, D. Okay, so I look at the grid and I found that those points are these, and that will help me determine, I'll use those to calculate, at this point, parallelism. All right, let's remember what the slope formula is. Okay, and then let's go ahead and calculate the slope of AB. So the slope of AB. Okay, so I calculated it to be 3 over 2. I'm going to calculate the slope of CD and see if it's the same. If it's the same slope, then indeed we have parallel lines. I want you to go ahead and find the slope of CD. Okay, go ahead and do that on your own. Go ahead and put me on pause now. All right, and I got the same slope for that one. So that tells me that these two lines are parallel. So I have opposite sides of being parallel. That's a parallelogram. Now we could check to see if it's a rhombus, and we could do that by checking the sides and seeing if they're the same length. We could check to see if it's a rectangle, and that we could do that by checking to see if the slopes are perpendicular, which they are not. So if you take a look, when we're talking about horizontal lines, the slope of that is equal to 0. Okay, anytime horizontal lines. Vertical lines have slopes that are undefined. Okay, so the slope of this line here is 0. The slope of this line is 3 over 2. And if you remember from my previous thing, perpendicular lines, lines that form right angles, have opposite reciprocal slopes, and 0 is not the same thing as negative 2/3. So we can conclude that this is not a rectangle. Okay? All right, let's move on. By the way, we could definitely look to see if the sides are the same length by using the distance formula. Um, Horizontal lines, we could just simply count the units. When they're straight across like this, we can just count the units. So that would be 1, 2, 3, 4, 5. This have a length of 5. And we could use Pythagorean theorem to find out what the distance of this one is. This is counting the sides as 3 and counting the sides 2. And so we'd use Pythagorean theorem to find out what this is and then compare them. Now, I'm pretty confident that is not a rhombus because it's drawn in the coordinate plane pretty much to scale. So let's move. Okay, so let's take a look at this shape, see if we can determine if it's first of all, it's obviously a quadrilateral. Let's take a look at it and see if it's um, a parallelogram, if it's a rectangle, rhombus, those kind of things. So I'm going to start off with the four sides, seeing if they're parallel. Let's use the slope formula. All right, so go ahead and use the slope formula to calculate those four slopes. We'll just check them out, see which ones are parallel, which ones are perpendicular, if any at all. Okay, we're going to do something else with this figure to practice, but for right now, I just want you to get used to doing the slope. I'll write them up there in just a minute. Okay, let's see if we can determine if these have anything that's parallel. So if you look at BC, this one over here, look at BC, it has a slope of 1. And then looking at AD, it has a slope of 2/3. So those are not the same, so we know that those are not parallel. All right, let's take a look at AB at the top, -1. And then let's take a look at DC, and we get -3/2. Okay, so I think I just said this. Oh, yeah, I said that right. So that's -3/2. And so let's see, those two obviously are not the same, so they're not parallel. Let's take a look at some of the other things that are kind of going on. Look at AB and BC's number. I have -1 and 1. We need to recognize that represents two sides that are perpendicular. So I know from that they're opposite reciprocals. They are perpendicular over there. Okay. Now, as well, if you take a look at the -3/2 and the 2/3, those are opposite reciprocals. One's negative, one's positive, and then the numbers are flipped. So that tells you that the angle in between CD and AD is right. Okay. Now, that doesn't say anything about parallelogram. We already know it's not a parallelogram because the opposite sides were not parallel. So we don't have to worry about it being a rectangle, don't have to worry about it being a rhombus or anything like that. I just wanted to take a look at that so you understand how slopes play out to help us see if things are right angled. Okay? All right, let's move on. Again, you're going to get some practice in class on this. So let's take a look at calling this A, B, C, and D. What we're going to do is we want to determine what kind of shape this is. So let's put these points down, and then we're going to go out using it, distance formula, slope, whatever we need to do to kind of prove it is one of our special parallelograms. All right, so let's look at finding slopes. All right, let's go ahead and find those two. Go ahead and do the calculations and see what you get. So I got the slopes for AB and CD be 2/3 and 3/5. So right there, I can tell you that these two do not have the same slope. So I don't need to worry about it being a parallelogram because I have two sides automatically right now that are not the same slope. So It's not a parallelogram. Now, if this had been, a couple sections from now when we've talked about trapezoids and kites, we might go a little bit further in this problem to take a look at, could it possibly be a trapezoid? Maybe look at the other pair of sides and see if they're parallel. All right, let's take a look at this one. A little slight variation. Okay, so you have negative 4/5, negative 7, not 4/5, negative 7 comma 5, negative 7, oh my goodness, negative 4 comma 5, negative 7 comma 3, negative 5 comma 2, and then 0 comma negative 2. Okay, so what I want you to do is I want you to go draw those, put those points down, and then I want you to look at the slopes of all four sides and see if you can see if any of them are parallel. Put me on pause and come back. All right, so clearly I see that these two are parallel. Okay, so we get to mark those as being parallel. And then clearly these two are congruent or equal to each other, so that proves that those two are parallel. So right now I have a parallelogram. So now what I would want to do is find out if the sides are all equal to each other. I can tell by the slopes. Let's take a look at BC, this side right here. Its slope is negative 5/2. Take a look at CD, this one right here. Its slope is 2/3. These are not opposite reciprocal, right? And so that tells me they don't meet at a right angle, which means it's not a rectangle. So now I'm going to just look at the sides and their lengths. Now I could actually calculate the sides using Pythagorean theorem. So I'm going to use my distance formula, but I'm going to show you an easier way to do it in just a second. So I'm taking the segment AB and I'm going to find its distance. Now I'm not going to go find the segment CD's distance. I've already proved that it's a parallelogram, so I know that opposite sides are congruent as well. What I really want to know is AB the same length of AD? And if it is, then I know now, then I can conclude that it's a rhombus, right? All the sides are congruent to each other. I've already shown why I know that it's not a rectangle by looking at the slopes and they're not opposite reciprocal. Okay, so just doing that math there, I get the side equals square root of 13. This is kind of a trick here. I could care less what that is as a decimal. I'm just going to simply now go find the square root of this side, go find the distance of this side and see if it equals square root of 13. If it doesn't, then I know that it's not congruent to each other. I could care less what it really ends up being as a decimal. So go ahead and put me on pause, and so go calculate the distance of AD. I got that side to be square root of 29. And so that immediately tells me that this is not a rhombus. The two sides are not congruent to each other, therefore all the sides. We know that this side, without doing any calculation, is square root of 13. Now let me show you maybe a little bit quicker way of doing this. So remember I was telling you that the distance formula is related to the Pythagorean theorem. If I wanted to find the side AB's distance, I could take the points and calculate them, the distance between these two, and just plug them into the distance formula, the x's and the y subtracted and all that stuff. But the other way I could do it is I could simply draw a right triangle with that thing being my hypotenuse. And I could count my sides and say that's 2 and that's a 3. And I could use Pythagorean theorem to calculate what that AB is equal to. Remember, it's squared. And so this ends up being 4 plus 9 equals AB squared. And 4 plus 9 is 13 equals AB squared. And if I take the square root of both sides, I get AB is equal to square root of 13 the same way. Now, so in the coordinate plane, it's easier for you to use Pythagorean theorem. You go right ahead, right? You just simply count them. So if I wanted to know the distance of the blue line here, I'd represent a right triangle here and just count them. 1, 2, 3, 4, 5. The side here is 5. This side's 2. And I'd use Pythagorean theorem to find out what the blue line is. It's whatever you like. All right. So I just wanted to give you a taste for how you use the slope and distance formula again in the coordinate plane, and you have to know your properties of your parallelograms to know what you should go looking for. Distance of sides that are equal each other, maybe perpendicular slopes and stuff like that. All right, so here's your three problems I want you to do. Only one of them is from this unit. The other ones are review questions, okay? So you have number one, if I was you, I'd go ahead and plot those points. Don't make any guesses. Come up with facts. Um, if you look at the top, it says, don't forget to neatly organize and show all work and equations. So you should have an area to say, hey, I'm proving it's a parallelogram and show that. Hey, I'm proving that it's a rectangle or not, and here's the information for it. I'm trying to show that it's a rhombus and so on. Okay? Make sure you have that neatly organized. And then the last two problems are just review problems from circles. Okay? Good luck, everybody. Have a good one.